Okay, hello everybody and welcome to my update. Well, today we're going to look at the UK, and the UK is following pretty closely actually an exponential rise in cases. Now this is a problem because it's not really slowing down. The formula for that exponential rise is that so far, and it's this number, the exponent, which is kind of the slope, it expresses the percentage change, is 0.2517. Now I mentioned in another video that would that if it was 0.7, it would increase double in a day, and it's about a third of that, so it's doubling about once every 3 days. So let's take this here, just below 500. Okay, 1, 2, 3 days you're actually about 1100, so that's a little bit faster. But then this one started a bit 1100, 1, 2, 3, just under 2000. Okay, that's a little bit slower because it's a little bit variable. Okay, because you had these lower numbers. This is the new cases line, this is the cumulative cases line. Okay, how many cases we've had so far. So yeah, taking it from here, from 500, 1, 2, 3, 4, 5, 6, you're nearly at 2000. So that's a quadrupling in 6 days, which is the same as a doubling. Every 3 days it doubles, and then it doubles again. And the interesting thing about an exponential function, of course, that will go up forever, okay, until you've infected the whole population. You have to go off this exponential function and slow it down. The percentage increase has to decrease. Now, what's the percentage increase right now? Well, if you take that number 0.2517 and you do an exp function of it, exp, which is e to the power of 0.2517, which is on the formula there, you get this figure. You get 1.286. Okay, that represents, it goes from 1 to 1.286. That's 28.6% increase per day, which means actually that if you started off with 100 cases, the next day you'd have 128, and the next day you'd have 128 multiplied by whatever that number is, 1.28, which is 164, and then the next day you'd have 164 times 1.28, which is 210. Okay, which shows you that you've doubled in 3 days. It's day 1, day 2, day 3, day 4, and you're gone from 100 to 210. So it's just a little bit faster actually than doubling every 3 days. But of course, if you kept doubling like that, you are going to be in trouble. Okay, because it's not going to be so long before the chart would go up into the millions. And what you actually have for the countries that have fought the epidemic successfully is this percentage increase starts to fall off, and it needs to fall off. And the magical thing about it actually is it falls off with another exponential function, a negative exponential function, like that. It's another exponential function, but it's a negative one, which is fascinating actually, and that would form a log chart, which will also be a straight line. It's approximately a straight line. Okay, let's have a look at South Korea. South Korea did a lot better. What you want is the social distancing to give you a steep decline like that, a steep decline in the exponential function, and China's graph was like that also, and that gives you then fewer new cases per day, so your graph goes from being steep to becoming more and more and more shallow. And the steeper that falls, the steeper this percentage change falls, the better it is, the fewer new cases you get. So South Korea is heading for maybe 8,400 cases, whereas Italy, because its trend is still increasing at 15% a day, 12% a day, okay, it's down from 40, 50, but it's stayed above 20 for a long time, as we are in the UK. So we're sort of here somewhere. We're about 14 days behind Italy, as I showed before. We're heading for the same sort of number of cases as Italy. Okay, and on here I've plotted the modelling of the total number of cases for Italy going to 240,000 by my forecast so far, and this is the daily new cases, and this is the number of cases you'd have, let's say, have to be treated if each case was in hospital or needed treatment for 14 days. So you'd have to treat about 70,000 patients if they were all in hospital for 14 days. Okay, that's probably a large amount. It's probably not going to be that many. But just imagine that some of these people are going to be on ventilators, okay, certain percentage. So you might sort of say, well, so 5% or 10%. But it looks like you've got about a 7% death rate in Italy. So quite a lot of the patients are on ventilators for a long time. So you're going to have some people who are in hospital for a long time in Italy. The hospital beds, that's why they're so full, okay? That's one of the things. So I did forecast actually that the new cases in Italy will peak at about 5,600 a day or something like that by the 31st of March. Now, if you look at Germany, France and Spain and Italy, you can see again that we have the same kind of exponential graphs. Okay, Italy's slope here, Italy at the top, UK at the bottom, Germany, France and Spain in the bundle, all about the same in the middle. This is for like the last 20 days or so. 0.2332 is the slope of that one for Italy, 0.2498 for Britain, as I said, back to 0.25. It's not exactly the same as the other UK graph because there are a couple more points on this graph, okay? It's a slightly longer period of time because I'm going back to when the Diamond Princess passengers came off here, okay, and it was level for a while there. So anyway, it's the same sort of slope basically, and you can see that we are so many days behind Italy, and really it's only about 12 days, 14 if we're lucky, but it's more like 12 days we are behind Italy in terms of the case numbers, and we're on very much the same trajectory, okay? So we need much more stringent measures. I mean, basically we are coming up to something that's going to be like this. We're not going to be like South Korea with 8,000 cases. We're going to be like Italy with 250,000, okay, at the rate we're going. And that's just the cases that are counted. Because I think Italy also now has probably been sending people to hospital, but you don't know. The doctor on the Journal for the American Medical Association interview, which is a fantastic guy actually, which I'll link to from this video, said that some people are sent home straight away when they're tested positive if they're not too bad, but presumably they're just testing people when they're invited to come to the hospital or when they turn up at the hospital, like us. But I mean, I don't know, they may have a more liberal testing procedure than we do, because they have tested more people than we have. They've tested 70,000 against our 30,000 or whatever we've done, or 40,000. We may be catching up with them, but then they're going to be moving away. They've probably tested 100,000 by now, who knows. Yeah, let's have a look at an exponential function just in the last couple of minutes, okay? I'm going to do a little bit of math here. And, okay, the great thing about exponential functions is not only do they show up as a straight line on a log chart like that previous one, but the number of new cases, the rate of change, is also an exponential function with the same slope, 0.2565 for the daily new cases and 0.2517 for the total cases. That's a fantastic thing about exponential functions. And of course, if you put them on a log chart, they're both straight lines with about the same slope. What I'm going to do here is I'm going to create an exponential function that doubles every day, starting at 1. Okay, starting at 1. Okay, 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 94, 2048, 4096, 8192, 16384, 32768, 65536. There. 171, 72. I used to remember these numbers when I was a kid, and I can still remember them. 524288. 48576. That's how many bytes are in a megabyte. That's how many bytes are in a kilobyte. If I wrote 1024, it would be better. Okay, so let's take those numbers and put them on a chart before this video runs out. And there's your exponential function. Beautiful, isn't it? Not beautiful if it's a disease. Yeah? There's your exponential function. You see, it doesn't appear to do much at the beginning, then suddenly wallop, and it's up to 1 million after 20 days. Now, if you put a trend line on that, we've just got time, I think, to put a trend line before my camera runs out. It is perfect, but it isn't, you see, because I might have got one of the numbers wrong. Yes, I did. 128. There you go. Now, here's the exponential function, and it is perfect correlation. Perfect correlation of 1.0, and the slope is 0.6931, which is actually the log, the natural log of 2, because it's going up by a factor of 2 every day, every period, whatever that is. Okay, so day 1, you're multiplying 0.5 by whatever that is. That is actually 2, and you go into the number 1, which is where we started, and then it goes 2, 4, 8, 16, 32, etc, etc, etc. And on a log chart, if I can format the chart axis before the video ends, it's a dead straight line. You don't want to see that. You want to see this fall off on the log chart, and you want to see it fall off on the real chart. And it's not falling off at the moment for any of these countries, as you can see. It's a tiny bit falling off for Italy. And because it's falling off a little bit, that's giving you a high forecast. It needs to be falling off fast, as it did for South Korea, to give you a lower forecast. And you can only do that with more quarantine procedures. But it is really fascinating, because you've got that exponential function for the increase in cases due to the infection, and then you've got that decreasing exponential function for the percentage change due to the quarantine, and that gives you those wonderful epidemic curves that they show you. Okay, of new cases and cumulative cases and things like that. That's the new cases, that's the hospitalised cases, and these other kind of curves are the cumulative cases, which is like a historic record of how many cases you ever had. And my very, very tentative forecast for the world at the moment is 26 million. So I'm going to leave you with that. I hope we don't have 26 million cases in the world. I think yesterday's number is going to bring that down a little bit. So let's hope and pray that that is the case. I hope you enjoyed this video. It's a bit of a rush to get it in 15 minutes before my camera time comes to an end. I've got 35 seconds left, so with that I'm going to say good luck, stay safe, and see you soon.